Paper 1R, June 2016, question 4. So this question is about longitudinal and transverse waves. In part A, you have a picture of a teacher using a spring to demonstrate a longitudinal wave. So as soon as you see the word longitudinal, hopefully you think also of the word parallel. So longitudinal waves are waves where the vibration is parallel to the direction that the wave is traveling. So to make that happen in a slinky, what the teacher would have to do is move his hand forwards and backwards in that direction, along the direction of the slinky. So that's what question 1 is asking. Draw arrows on the diagram to show the direction in which the teacher moves his hand. So the arrow that I've drawn is absolutely fine. It can be a double-headed arrow. You could also draw it along the spring, and you could draw 2 arrows, but the idea is that it's moving backwards and forwards parallel to the direction that the wave is traveling. Part 2, give an example of a longitudinal wave. The easiest one and safest one to go for is a sound wave. Ultrasound is fine too. Another answer that you could have is a P wave, which is a type of seismic wave. Part B, teacher then demonstrates transverse waves. So he's going to do that using water waves in a pond. So he's fixed a vertical rod and put a small wooden ring on the rod. And because the ring floats, it will move up and down as the waves go past. So it can't move side to side, it's fixed, it can only move up and down. So first question is, on the diagram, draw a line to show one wavelength. So one full wave. Easiest way to do that is to go from one peak to the next peak. Draw your line, a little bit neater than I did, and make sure that you label it. Okay, don't lose a mark just because you don't read the question. Now the next part says the distance from P to Q is 5 centimetres, so it's this vertical distance now. Determine the amplitude of the wave. So the distance from P to Q is the whole height of the wave, all the way from the peak down to the trough. And as you hopefully know, the amplitude is half of the total height of the wave. So it's the distance from either the peak to the centre or the trough to the centre. That's your amplitude. So if distance from P to Q is 5, you need to divide that by 2. Make sure you give your answer as a number rather than a fraction. So the next part says the wooden ring reaches point P every 15 seconds. So point P is the peak, as we discussed before. So it takes 15 seconds for this peak to travel to there, and that's the definition of the time period of the wave, the time for one full wave to pass by. So that's time period. It wants you to calculate the frequency. So again, that's a clue. Even if you didn't realise that the 15 seconds was the time period, if you are asked to calculate the frequency, hopefully you're going to think either of the wave speed equation, but we're not really talking about speed, or you're thinking about this reciprocal relationship. Now you don't get any marks just for writing that down because it's given to you at the start of the paper, but you do get marks for putting the numbers in. So 1 over 15. You get another mark for the answer, and you can round that to 0.07 if you wanted to. And then the third mark, as usual, is for the unit, which is hertz. Now, if you've got good habits, unlike me, you'll then make sure you're popping it in the right place as well. So part 4, explain how the movement of the wooden ring demonstrates that this wave is transverse. So just like the word longitudinal should make you instantly think of the word parallel, hopefully if a wave is transverse, that instantly makes you think of the word perpendicular. Now it's for 2 marks, so you've got to make sure you are clear about what is perpendicular to what. So perfect answer, the direction of travel of the wave is perpendicular to the vibration. I'm running out of room, not going to write that out. So you could say, in this case, vibration would be okay, the movement of the ring would be okay, the oscillation of the ring would be lovely, but it is the idea that the direction of travel of the wave, it might be nice to put a little arrow to go with that, is perpendicular to the vibration. And do some arrows to match the diagram above. Last part of the question, the wave shown is a water wave. Give a different example of a transverse wave. Be careful, there's so many people, they're rushing, they don't read the question properly, and they'll write water wave in there. That one's gone, can't have that one. So the next easiest example is any kind of electromagnetic wave, or just electromagnetic wave. So you could state that, or any example, something like light, radio, UV, any of the 7.